We are solving nth root and rational exponents, and here we're going to solve those equations. So when we're solving these, we got to go back to inverse operations, and so we're looking at GEMDAs. If we evaluate, we start with groups and we work our way to subtraction. If we are solving, we start with subtraction. In addition, we work our way to groups. So we have to check for addition and subtraction and multiplication and division before we can deal with these exponents. So over here, if we're looking at example A, we don't have any operations other than the cube of x. So we can get right into solving this. So x cubed is equal to 64. And then we can take the cube root of both sides. And the reason that we did that is because we want the cube root to cancel our exponent there. So we get x is equal to, and in this case, our solution is 4. And we don't have to do plus or minus in this case because we have an we have an odd radical or an odd exponent. The next one that we come to, we have 3x squared equals 108. And we see that we have an operation that we have to deal with before we get to the exponent. So we divide by 3, and we get x squared is equal to 36. And in order to get rid of the exponent here, we have to take the square root of both sides. We don't have to write down the 2, that's understood. So the radical cancels the square. Because we took an even radical to solve, that means that we have to say plus or minus. So x is equal to plus or minus 6. Again, if we look at C, we have an operation that we have to mess with before we can deal with the exponent of the 3. And so we have to multiply both sides by 4. And then we get x cubed is equal to negative 64. Then we can take the cube root of both sides to get rid of that x cubed power. And we get x equals negative 4. A couple more examples. In this case, because we have the parentheses there, that group, when we're solving, that's the last thing that we have to come to. So we get to mess with the exponents and undo the exponents before we deal with what's inside this parentheses here. So I'm just going to rewrite this. X plus 5 whole binomial raised to the 4th power equals 16. And we can take the 4th root of both sides. And in that case, it gives us x plus 5 equals plus or minus 2, because we had to do plus or minus 2 because we had we're taking the even root. And then we subtract 5 and subtract 5. So then x is going to be equal to 2 minus 5, and x is also going to be equal to negative 2 minus 5. So 2 minus 5 is negative 3, and negative 2 minus 5 is negative 7. Next one we come to, in this case, we don't have the operation inside the parentheses here, so we have to do the 43 first. So we can subtract 43 from both sides. and we get x cubed equals negative 343. And then we can take the third root of both sides, and that gives us x is equal to just negative 7 in this case. And the last one, we can take the fourth root of both sides, and we can't get an exact answer, but we're taking the fourth root. So we're going to say x minus 3 equals plus or minus the square root of 21. So now we can add 3 to both sides, and then we get x is equal to 3 plus or minus the square root of 21.